Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za. Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
It is now 23 minutes to 10 o'clock, very late for the Naked Scientist today. Beg your pardon. All the strike action and is big news in South Africa, and we're very sorry to be going to the Naked Scientist late. But our lines are open for you, so use this opportunity on 021-446-0567, 011-883-0702. We're taking your SMSs as well on 31702 and 31567. Don't forget, the Naked Scientist is brought to you by Grolsch Premium Lager. Grolsch Choose. Interesting. Not for sale to persons under the age of 18. Chris, good morning. You've got some great news about solar panels. Are they about to become lighter and cheaper?
Well, let's hope so. Morning, Reedy. Morning, everybody. Yeah, interesting story. This was published in the journal Nature in the last week, and it's a piece of work actually from the University of Liverpool in the UK. Scientists there have discovered a way of making much cheaper, much safer, thin film solar panels. So backing up a little bit, solar panels are very expensive, and these are the panels to generate electricity, because they have to be a big chunk of silicon that sits on your roof, and they have to be a big hefty slab of silicon to make them efficient enough to capture enough energy from the sun to make electricity at a reasonable rate. What would be better is if, instead of having to use these very big, heavy hunks of silicon, we could have something much lighter and therefore using fewer materials, costing less money, and meaning your roof doesn't need reinforcing. And that's exactly what this group, led by John Major at Liverpool University, have achieved. People have been investigating thin film solar panels for a number of years, and they've found that a very good recipe for them is to use the chemical cadmium telluride. And the problem is that in order to put the two materials together like a sandwich, you have to flow in between them a chemical called cadmium chloride, which is vile. It is rotten for the environment, it's very toxic, and as a result this has meant that any savings made by making these things very thin and light are more than offset by the fact that the environmental cost of doing this made it uneconomically viable. But what these researchers at Liverpool did was to say, well, why don't we try some other chemicals and just see if they'll work instead of this cadmium chloride? So they just tried a whole mixture of different things, including one chemical called magnesium chloride. Magnesium chloride will be better known to most people who are in the industry as the stuff you use to coagulate your tofu. So when you're pulling together your tofu to make it form nice, stodgy stuff that you can then make delicious snacks from, you use magnesium chloride. It works a treat in these solar panels, and it's dirt cheap. You can buy bucket loads of it for not very much money. So what they're suggesting is that we don't have to use this horrible, hideous, toxic stuff anymore. We can use magnesium chloride, and as a result, the cost will plummet, and it'll be much easier to make these panels cheap and light, and therefore the cost of solar power will be significantly reduced, which is really good news. And one has to speculate, how did someone discover this in the first place? And some jokers have said, well, maybe someone spilt their lunch in the lab onto their experiment, and then I'm sure they didn't do that, because no one would eat in their laboratory. But it's an interesting story, isn't it?
It is indeed, it is. Now, Chris, I can't remember whether this came through on the show or whether I saw it on your Twitter account. It is about being a morning or evening person. Are you a morning person? Apparently, we are less ethical at night. Did that come through on the show? Where did I see that?
I haven't seen that, but it's perfectly possible that our behaviour does change during the day and during the night, because your degree of alertness, your degree of arousal, how well you feel is going to differ. And we know that people in the population fall into different categories. There are so-called larks. There are some people who love getting up in the morning, they feel best in the morning, they're most active, they do their best work in the morning. There are others who are, I mean, I'm one of them, who just can't cope with getting up early in the morning and not at your best, certainly not before a cup of coffee. But as the day goes on, feel that you become more productive, more effective, and actually feel that you do some of your best thinking late at night. And this seems to be down to genes and what particular clock genes you carry, because your body clock is a genetic clock. You have this system of genes ticking away in a cluster of nerve cells in the middle of your brain, and different variants of the genes that run that clock give people their clock characteristics, making you a morning person or a nighttime person. So I wouldn't be at all surprised if some of those same changes also affect people's tendencies to make decisions differently according to what time of day or night it is.
Do you have any questions for Chris? Give us a call. 021 446 0567 011 883 0702. Now, Chris, I read an article recently about e-cigarettes. I'm not in any way interested in taking up the habit, but I wonder how they work. What's an e-cigarette? And is it less dangerous to your health?
Well, it's certainly a burgeoning industry. There was a paper that came out a couple of weeks ago, and they were saying that something like 650 new brands or flavours of e-cig are being launched every week. Huge numbers. And there's some controversy here because on the one hand, some people are selling them, and the people who make them are selling them as a healthy alternative to smoking, a healthier alternative to smoking. Others are saying, well, we need to question this because it hasn't been tested as to whether or not these things really are safer. They're unregulated in pretty much all marketplaces at the moment, and we don't know if they act as a gateway drug. In other words, once people start with those, will they become smokers? Or the flip side, do they genuinely help people to give up smoking? We just don't know, so we need to investigate. But the way they work is that you've got an element inside, you feed in a starting material, nicotine, for example, and the element vaporizes the nicotine by heating it to a high temperature, making a vapor that you breathe in, and it then delivers the nicotine into you. A cigarette does exactly the same thing, except it does the vaporizing by burning tobacco. It therefore produces smoke, and there are thousands of chemicals in the smoke you breathe in, many of which are very bad irritants to your airways, many of which also damage your DNA and therefore place you at risk of cancer, as well as producing a risk of heart disease and stroke. And for that reason, e-cigarettes are judged to be a safer alternative because they don't have those tars and other chemicals that will damage your DNA. They just have the nicotine in them. This means that you will satisfy your need for nicotine. You will still find them addictive, but you will not be subjecting yourself to the health harms of those other chemicals that come with a cigarette.
Let's go to Seth on the East End. Good morning to you, Seth.
Hi, morning. How are you?
Fine, welcome.
Good, thanks. Chris, I'd like to ask, if a chameleon was to lose his eyesight, or perhaps an octopus, would they still be able to change colour and blend with the environment?
Oh, hi, Seth. The answer is they would definitely still be able to change colour. Chameleons don't necessarily blend with the environment. They use their colour not as a means of camouflage, but as a means of signalling. And they do it because the layers of their skin are stacked up in layers of these cells called chromatophores. And you have a top layer of red ones that I think they're called red ones. So they'll be the... I'll have to think about that. Erythrophores. And then underneath those you have yellow ones called xanthophores. And then underneath that you have some iridophores, which make a blue colour. And underneath that you have some melanophores, which are the brown ones. And the way these cells work, they're wired up to the nervous system and they're wired up to the hormones in the blood. They have receptors on the cell surface which can detect the chemicals going around in the bloodstream. Those signals tell the colour cells to discharge the colours, because if you looked in those cells under the microscope, you would see that the colours are all sequestered in tiny packets called vesicles, and they're kept there until the signals come in from the blood or the nervous system, and they tell the cell discharge, and the whole cell fills with the colour. And it's a bit like you throwing a bucket of paint up a wall. Instead of the paint being in the paint pot and not changing the colour of the wall, as soon as you throw the bucket of paint on the wall, the whole wall goes red or yellow or brown or whatever, changes its colour. And because these cells are lined up underneath each other, you get the ultimate colour of the skin is the sum total of all of the colours mixed together across the full thickness of the skin. And because that's driven by a nervous signal and also by a blood signal, they can do it without being able to see. And they actually do this in order to signal their mood. So a chameleon, when it's calm, is a nice pale green colour. A chameleon, when it's feeling randy and wants to mate with another chameleon, will resort to various colours, including flashes of red and yellow. And when they get angry, they can produce all kinds of sort of very, very bright, vibrant colours to say, hey, I'm getting angry, watch out. Other animals do use it to blend in. Cuttlefish, octopus, that kind of thing, they'll blend in by using their visual system, but maybe also some local sensing too. So I don't know that they're entirely dependent on their visual system to produce those colour changes for camouflage either. That may be also governed by other mechanisms as well. But certainly they can still change colour without being able to see.
Thank you very much, Seth, for that fascinating question. Now that you mentioned visual senses, Chris, I have a very close person who's a young woman who's blind in my life. And I find very often she's able to just predict. I don't see her every day. I mean, sometimes 4 or 5 months, but she's able to assess my mood accurately. And I'm fascinated by that because she'll say, "Really, I'm not feeling your energy today," or are you anxious, or are you excited? And I've asked her about it, and she says that because she's blind, she's managed to, just subconsciously to fine tune her other senses, and she feels she's more alert in that regard, precisely because she doesn't have vision. Is there any science to this?
Definitely. And if you ask a blind person, they're robbed of the dominant sight. We put enormous emphasis on being able to see. If you take away that dominant sense, then people become extremely good at using the other senses that we're endowed with to replace some of the impact that being able to see would have given them. And this includes listening to pick up minute sounds. It includes feeling vibrations in the air a bit more sensitively. It involves feeling temperatures. When they run their hands over your face in order to feel your face, then they're also not just picking up the shape of your face, but also perhaps the texture of the skin, whether there's a fine bit of sweat there, which tells them things. And without realising it, all that information is being integrated back into their mind, and they're able to think, well, okay, so I've got someone here, they're speaking slightly differently than they would do when they're relaxed. There's a slight edge to their voice. I can feel that they're stiffer. They're sitting there because their voice, the way they're making sounds is different. The way they make the chair creak is slightly different because they're sitting there more rigid in the chair. And these people become extremely good at bringing together all these things and building a mental picture because they can't see the person. And it's very powerful. And friends of mine who are blind tell me that, that they can pick up, even they still use the word see. They often say, I see that you're out of sorts today, because in their mind they are actually seeing you. They're just seeing a picture they're building in their head rather than actually physically one coming out of their eyes. But they're very tuned in to those signals for precisely that reason, that they devote a lot of the sense in their brain that would be taken up or totally, I suppose, drowned out by being able to see, because see is such a dominant sense. They become very tuned into these subtle signals that most of us would be oblivious to.
Oh, it freaks me out every time she says, "Why are you upset?" After when I've only said, "Hello, how are you?" and she says, "Why are you upset today?" That freaks me out. George in Rosettenville, good morning.
Good morning. What I'd like to know is if the hydrogen and oxygen...
Yes, George? Okay, George wanted to ask if the hydrogen in water can be separated, basically. If the particles that make up, the elements that make up water could be separated.
Yes, George, you can. Sorry about your phone line. Water is H2O. That's two atoms of hydrogen glued onto one atom of oxygen.
Yep.
And if we put energy into water, you can do this most simply with electricity, then you can break the bond between the hydrogen and the oxygen. You can push electrons onto the hydrogen so that it will then form H2, hydrogen gas, and you can rob the extra electron off the oxygen, which will form O2, oxygen gas. And so if you pass an electric current through water, then you will get hydrogen gas and oxygen gas. You can collect the two of them separately because the hydrogen will come off at the negative terminal and the oxygen will come off at the positive terminal. And if you get those two gases, mix them together and then light them, you'll get back to water again. And that's exactly what we think we can do with a hydrogen economy. We could use hydrogen as a very environmentally friendly fuel in future.
Let's go to James in Midrand. Hi.
Hi, Chris. My name is James in Midrand. My question is, I want to know how are hurricanes named? Because you find Hurricane Anna, Hurricane Katrina, and so on, but there's not even a single African name like Hurricane Reedy and so on.
Listen, where I live, they'll tell you there's Hurricane Reedy, but anyway, we won't go there.
Well, they're always named after women. I don't know what the point of that is all about. I'm sure that's to do with the fact that women are calming and very relaxing to be around, and therefore if you name a storm after a woman, then hopefully that will calm the storm down. Perhaps that's the theory. They go up the alphabet. So they start with an A at the beginning of the year, and they work through giving the tropical storms and hurricanes progressively further through the alphabet female names. and that's why you end up with, you know, M's and N's and P's and things, because there are lots of storms that never really make the news, but they're still storms and they get a name nonetheless. I don't know why they started naming them after women, and I think it's a great idea to introduce some diversity here.
Yes.
I could just see that being fun, but I can't see it going down well with these Americans who won't be able to say them, because they're not terribly good at that kind of thing, are they, American people? So sorry all American people who are listening now. We just alienated half of them. Sorry about that. I'm just kidding. No, I think that'd be a great idea. So American people, start naming some of your hurricanes after some Africans. Let's see what happens.
Yep. Sakile in Santon. Hi.
Hello, Riri. How are you doing?
Good. Your comment or question?
I want to quick ask make a scientist. You know, in the afternoon, when the sun is about to set, you normally see a group of birds flying quite high in the sky, and then they seem to have like a sense of direction. Do they have a place where they call home, where they know where that is, and they just fly straight to that place, or do they still look around on the ground to see where they can land and sleep for the night, or anything like that?
Yeah, I remember I asked a question like that a couple of years ago, because I'm also fascinated by that, Sakile. They just seem to know when to turn left, when to glide to the right, and go upwards. It's beautiful to behold. Chris?
Yeah, birds have an excellent sense of direction, and they have a very good visual system. They also have a compass in their head which is sensitive to the Earth's magnetic field in most cases, and they bring all of this information together, which enables them unerringly to find where they need to go. I mean, if you look at how far birds travel, they go thousands and thousands of kilometres when they migrate, and they very rarely get lost. So they know where they're going, they know what time of day it is, and they know that it gets dangerous when it gets dark because they can't see so well, because their sight is their main sense that shows them where they're going, and therefore many of these birds will seek shelter. They know where their roosts are, and they know how to find them, and they use all those cues that I've just mentioned in order to do that. So they're definitely going somewhere. They know what they're doing, and they also go around together because they can rely on each other for protection, and also for if one of them gets lost, they'll follow the others.
Thank you very much, then, Sakile. Chris, I just remembered. Do you have an answer for us regarding the yawning and autism link? There was a question from a caller last week. Were you able to find anything?
I do,
yeah?
and I do, and even one very kind person even sent me some new publications on this. So thank you very much to you people who did that, because a few people sent me some interesting things to read up about this. And the answer is that it was a very good question, and it's absolutely true. And that if you look at contagious yawning in autistic people, it doesn't happen. They don't catch yawns in the same way that people who are not autistic catch yawns off each other. And now I'm feeling like I want to yawn because I'm talking about yawning. But yes, it's true. And it's because we think that people who have Asperger's and autism type disorders don't socially identify, or they have an issue with being able to empathise and put themselves in the mind or in the shoes of other people. And so for that reason, because of that social relating problem, then things that are a social phenomenon like contagious yawning obviously happen to a lesser extent in them.
Let's go to who came in first. Let's go to Ruth in Rivonia. Hi.
Hello. My question is about the people who advocate spiritual growth, and a lot of life coaches today speak about the law of attraction. Is there something physical that could explain that? And it's a slightly related question, also linked to what people were saying about blind people. One can be with a dog in a room, and Rupert Sheldrake talks a lot about this. You can be with a dog in a room and pat it and hug it, and a dog somewhere else in the house comes to get attention. So they're related in the way of some kind of energy impulse or some law of attraction that is happening that I wonder if you could explain to us.
Hi, Ruth. Well, I don't know much about laws of attraction as related to spiritual growth. I know about the laws of attraction with magnetism and between two people. But in terms of patting a dog, you raise a very interesting point, because I said that blind people tend to develop an acute sensitivity to signals that most of us would overlook or miss because we're so busy being obsessed with what we can see. I think the same is going to be true with dogs. You've got to remember that where we live in a visual world, where we put enormous store on what we can see, dogs live in a smell world and a sound world. About a third of a dog's brain is given over to just what goes into its nose. A huge amount of its brain is devoted to smelling things, and its hearing is exquisite. And therefore, when you're patting a dog, although you think you're interacting with just that dog, you're sending out all kinds of signals that you might not be able to hear in the next room, but the dogs elsewhere in a house, they sure as hell will. They'll hear their fellow dog changing its behaviour and making subtle sounds. They'll hear the owner making subtle sounds, or even producing smells that you wouldn't necessarily be able to detect in your neck of the woods. They can, and they're very, very tuned to that. So I suspect that's at least part of what might be going on.
Thank you very much, Ruth. Thomas, do we have time for one more question? Yeah, let's go to Dabi in Pretoria. Hi.
Hi. I would like to know how come we can be able to be inoculated against disease that are being caused by viruses instead of disease that are being caused by bacteria.
Okay.
Could you just summarise the question again? So how can we be inoculated? What, sorry?
Yeah, he said, how come we able to get to be vaccinated against diseases that are caused by viruses rather than those that are caused by bacteria?
Okay, well, in fact, we can be vaccinated against both viruses and against bacteria.
Mm-hmm.
And the way this works is that in some cases you give the body a killed form of the organism. You take the virus, grow it in a dish, destroy it so that you've blasted it to pieces, or you blast the bacterial organisms to pieces. Then you inject that microbial shrapnel into the body, and the immune system sees those particles and it presents those particles to other parts of the immune system, showing the immune system what this looks like, so that then you get an immune response against that inviable form of the organism. But then when you are challenged with that organism for real, you already have the antibody sitting there ready. That's one form of vaccination. Another way of doing it is you can give what's called a live vaccine. And what scientists can do is to weaken the organism, either the virus or the bacterium, usually by growing it in culture or finding a relative of the organism that causes disease in us, but you find a relative that lives in another animal that can't really grow in us very well, but nonetheless looks like the bad guy in us. You then inject that into the person. They get a very limited illness, or they're not even ill at all, but this displays to the immune system the full genetic repertoire of what that organism can do, can make, and what it looks like, and then you make a very powerful immune response which involves antibodies and also cells, T cells, that can recognise the bad guys and attack them. And this gives you very, very robust, long-lasting, resilient immunity against those things, so that if you then meet them in the future, you can fend them off very, very quickly. And the last way of doing this is that some bacteria don't themselves cause too much of a problem, but they do produce toxins or other chemicals that can be really nasty. And a good example of this is tetanus. And when you get tetanus, the Clostridium tetani organism is making a toxin that damages your nervous system. And when you give people a tetanus jab, what you're doing is exposing them to a disabled form of the toxin rather than the bacterium itself, and the body then makes antibodies that can neutralise the toxin, so that if you do catch tetanus, although you've got tetanus, you can deal with that. The actual nasty bit, the toxin, is disabled by the immune system before it can get nasty.
Chris, we'll see you next week.
Okay, Reedy, thanks very much. Take care, bye-bye.
Oh, sorry, Thomas. The Naked Scientist was brought to you by Grolsch Premium Lager. Grolsch, choose interesting, not for sale to persons under the age of 18.